How do you get a reaction in life? Well, it depends on what kind of reaction you want to make happen. In chemistry, it is maybe a little bit more predictable. I'm André Isaacs, and this is 3 Chemical Reactions. Let's start with a precipitation reaction. This happens when 2 substances that are dissolved in a solution react to form 1 or more solid products. Here are our 2 solutions. One is copper nitrate, and the other is sodium hydroxide. Copper 2 nitrate forms a light blue solution in water, while sodium hydroxide forms a colorless solution in water. When we mix these together, the solution gets cloudy as a solid forms. What's happening at the atomic level? Copper nitrate is an ionic compound, and so it separates into its constituent ions in aqueous solution, copper 2 plus ions and nitrate ions. Sodium hydroxide is also ionic and separates into sodium ions and hydroxide ions. All these ions are just floating around in solution. So when a copper 2 plus ion meets 2 hydroxide ions, they stick together to make copper hydroxide, which is insoluble in water. This is a blue solid. It forms a precipitate. As they say in chemistry, if you're not a part of the solution, you're a part of the precipitate. Simple, right? Now, let's consider an acid and a base. In a general acid-base reaction, a hydrogen ion, H+, is transferred from one chemical species to the other. When the other species is hydroxide ions, the 2 ions combine to make water, and we call this a neutralization reaction. For example, let's look at the neutralization reaction between HCl, an acid, and NaOH, a base. We're going to bring out the cool equipment. You're not a real chemist unless you've done a titration. And what we're going to do is we're going to use this burette to add some sodium hydroxide bit by bit to the acid that we have here in the Erlenmeyer flask. But wait, hold on. Both HCl and sodium hydroxide are colorless solutions, you can see here. Water, the product of the reaction, is also colorless. How do I know that they've reacted? Well, we have a trick. What we're going to do is we're going to use an indicator, phenolphthalein, to follow the reaction. In an acidic environment like HCl, phenolphthalein remains clear, but in a basic solution, it turns bright pink. So let's visualize this and let's titrate. As I add some sodium hydroxide, it might look like nothing is happening, but at the atomic level, each added hydroxide ion is reacting with an H+ ion to make water. Now we have fewer H+ ions. As I add more sodium hydroxide, we reach the right amount of sodium hydroxide to react with all the H+ ions. At this stage, all the H+ ions and hydroxide ions have reacted, and the acid has been neutralized by the base. The solution, you can see, still remains clear. But the minute I add more hydroxide ions, the solution will turn pink. There are no more H+ ions left to react with. Excess hydroxide ions remain in the solution, causing it to be basic and hence pink. Finally, let's do a redox reaction in which electrons are transferred from one atom to another one. The chemical chameleon reaction demonstrates the reaction between potassium permanganate, which is pink, and sugar solution under basic conditions. Let's add the basic solution of sugar to the permanganate solution. The solution turns to blue and then to a lovely blue-green. Finally, it will turn yellow. Why is this happening? Essentially, the potassium permanganate is reduced or gains electrons, and the sugar is oxidized or loses electrons. The reaction mechanism is intense, so let's simplify what's happening to cause this color change. The manganese ion in potassium permanganate starts at an oxidation state of +7, which means it has a charge of +7. The sugar provides an electron to the manganese and its charge then goes from +7 to +6. As another electron is provided from the sugar, the charge on the manganese changes from +6 to +5. This reaction will eventually continue. So maybe getting a reaction is not so difficult in the lab. And there you have it.